lesson 1.9. It says we're going to use proportions, which we know what a proportion is now. We know how to use them to solve problems involving geometric figures. So now we have to bring our geometry skills into this, because that's our learning objective for today. I can use proportions to solve problems involving geometric figures. What page? 69. Page 69 in your books is lesson 1.9. Okay. So, similar figures. When we talk about geometry, now we're going to start talking about some geometric terms. Similar figures have exactly the same what?
Shape.
Shape. They have the same shape. They have the same shape. If I have something that is similar to something else, it has the same shape, but not necessarily the same size. It doesn't have to be the same size. So when you enlarge a photo, let's say you have a 4x6 photo. If you enlarge a photo, it's a rectangle to start with. When you enlarge it, it's still a rectangle when you're done. It'll just be bigger. They're similar figures. They're going to still have the same shape, but they're just going to be different sizes now. And notice it says, but not necessarily the same size. So when we have two figures that are exactly alike, they still are similar too, because they have the same shape, but they just also happen to have the same size. Corresponding sides and angles. We're going to understand what that means, because we're going to work with corresponding sides and corresponding angles. So corresponding sides and angles of similar figures are in the same relative position. So if that enlarged photo is sitting face up, you're not looking at it upside down or sideways, the upper right-hand corner of that photo would be in the same position as the upper right-hand corner of the other photo. So same position means in the same, or corresponding means in the same relative position. When stating that two or more figures are similar, there's a mathematical symbol, and that's what it looks like. So when you see that mathematical symbol, you'll know it says is similar to. Okay? So that shows that something is similar to something else. Okay, so what happens is, when we have similar figures, we can set up ratios of corresponding sides, and then those ratios can be set equal to each other to set up a proportion to solve for missing information. So to find missing lengths in similar figures, you must know which sides correspond, which sides are in the same relative position, which sides kind of match up. And you can use their letter names to help you match up their corresponding sides, because they're not always sitting in the same position. They don't have the same orientation, so sometimes using the letter names is more useful. Okay, it's Jessie.
Isn't this just like review? I think I've done before.
From which one?
Like all of this.
From another class, probably. Yeah, it should seem like review to you. Absolutely.
This is like our like math from 8th grade.
8th grade, did you do this in Math 8?
Yeah.
Okay, good. So we're going to set up ratios of corresponding sides, and we're going to replace the names of their sides with their lengths. Okay, so let's just do that first of all. We have right here, it says that we have triangle ABC is similar to triangle DEF. So give me a pair of corresponding sides from those two triangles. Julia? Okay, AB corresponds with DE, so we're going to set it up in a ratio. We're going to say, we could set up that ratio of corresponding sides. We could have AB over DE. We could have them being compared to each other. Let's replace that with their, let's just set up even their numerical values now in place of them. So do we know what the length of AB is?
Yes.
What is it?
7 feet.
7 feet. So let's just do the 7 for right now. Because AB with nothing over the top of it, those letters just AB, that means length AB. So the length of AB is 7. What's the length of DE? Do we know it? 9.1. So it's 9 1/10. Okay? Okay? That's just one of the ratios that we could use in our setting up a proportion. Okay, what's another set of ratios? Another set of corresponding sides we could set up a ratio for. Cody?
AC is equal to DF.
AC is corresponding, they aren't equal
Corresponding
necessarily.
with
AC corresponds with DF, okay? So in other words, those letters are in the same position in their names, aren't they? A and C are in the same position as D and F in the other one. So how long is line segment AC? 10. How long is line segment DF? 13. Okay. Okay, are there any other corresponding side relationships we can set up in this pair of triangles? Jossie? EF and BC, but we're going to stay with the one on top is going to come from the same triangle, so we're going to say BC because we have in our other ratios we were using the letters from the first triangle in our numerator, so we got to stay with that. And then BC corresponds with what, Jossie? EF. Okay. Okay, do we know the length of side BC? What is it?
12 feet.
12, okay, 12 feet. And do we know the length of side EF? No, it is
X.
X. Okay. So now, this is what I want you to do. I want you to set up all the relationships you possibly can from it. If they're three-sided figures, you should be able to set up 3 ratios. If it's a 4-sided figure, how many ratios should you be able to set up? 4. Yeah. So we need to find the value of X in the diagram. So which of those ratios do we absolutely have to use?
AC over DF and AB over D.
Which one do we absolutely have to use?
BC and EF.
BC over EF, because that one has X in it. We have to use that one. Otherwise, how are we going to find X? So we're going to do 12 over X equals, and now we only need to use one of the other ratios because we only need one more ratio to set up our proportion. So which one do you want to use, Noah?
10 over 13.
10 over 13. Don't have to deal with the decimal, right? Okay. And now we'll do our, what's that called? Cross products, yeah, cross multiplication. So we're going to do X times 10 is equal to 12 times 13.
Does it matter, would it have mattered if you used 10 over 13 or 7 over 9.1?
Wouldn't have mattered, we should get the same answer. Okay, so this side is going to become 10x. The other side is, what is 12 times 13?
156.
156, yeah, okay. So what's our next move? Maddie? Yeah, thank you for saying it that way. Divide both sides by 10. And you don't need your calculator to divide by 10 because you just do what? What's the shortcut?
Move the decimal to one place over to the right.
To the left.
To the left, yeah. Move it one place to the left. So x is equal to what? 15.6. And what's the label on this?
Feet.
Feet. Yeah. X equals 15 and 6/10 feet.
So you only need to do one of the,
Other ratios? Yeah. Did anybody work ahead and use the 7 over 9.1 instead of the 10 over 13? What do you think we would get if we did?
Some decimal.
Same answer. We better, if we use the other one, we still better get the same answer. They're all part of one big problem, and it's they can't, or the same two pair of triangles. We can't come up with a different length for that side. Okay. Go ahead and set up all the relationships underneath the name of lady and gent here. We have a 4-sided polygon similar to another 4-sided polygon. So they're quadrilaterals this time. So how many ratio relationships should you be able to set up? I don't want a proportion yet. 4 ratio relationships that you'll then replace with, oh, in this one we don't need to have 4 though, because what? How many do we only know from the first one?
2,
1, 2, 3. So we'll set up 3. Set up those 3. Okay? So you don't need to worry about EG. So you're gonna do, in this case, might be better to work start with gent. So in other words, we're not gonna use the GE one. So we're gonna start, we can use EN. So EN corresponds with which side? AD. Okay, everybody see how we're making that decision? EN are the middle two letters of gent, so we need the middle two letters of lady. Another one that you can set up is ET over what? What would ET correspond with? AY. And then we have one more. We're not going to do the first two letters, but we could do the first letter and the last letter. We could do GT over,
I'm confused with some of these though, because some of the lines are blank and don't have a line.
right, LY. So this is the only one that's blank on this one though, so we're going to set up three of them. So we're going to use these three. So do we have EN in one of them? Yes, we do. Do we have NT in one of them? No, we don't. We need that one. Do we have GT in one of them? Yes, we do. ET,
Yes.
why do we want ET? Is there a side called ET?
No.
No, there isn't. We got to get rid of that one. We don't want that one. That's not a good one. There's not a side ET. So instead, we said we have EN, we have GT, we need NT. That's the one we need. NT corresponds with what? DY. Okay. Now we can go backwards like this and say, okay, what are their values? Replace the values in them. So we have question mark, we don't have that one, do we? Okay. So in reality, the only two that are useful are those top two, aren't they?
Yep.
Yeah, we have to use those two. Because we didn't know what LY was either, so we couldn't use it. We can't have two unknowns. And so we're gonna have to use these two. So we're gonna do 2 over 3.5 is equal to 3.5 over x. Those are the two we're going to have to use. Show your cross products, show your dividing step, and what is x equal to. What's 3.5 times 3.5? 10?
Just
12.25.
12.25. And then we'll divide by 2. Cody?
6.125.
Yeah, 6.125. And what would the label be on that? Centimeters. We always want to make sure we go back and look what was the label on these side lengths and give our missing one that we were finding its place. Okay?
Yeah,
So
just
this-
have a question.
Do you have to do the question mark in that one that was blank? Okay. So, because that would end up being useless to us, didn't it? Ended up not being any good. Okay, any questions on that one? Okay, then let's go to the back side and see if we're continuing to do this, or, yep, looks like we are. Okay, so, find the value of x in the diagram. Well, you know what? Let's do it this way this time. Let's look at the first one and say, we know side VR, so we're going to do VR. And what side does VR correspond with?
RS.
Yeah, but I'm going to do it in the order it was, yeah, SR. Okay? And we know that the length of VR is
10, and the length of SR is
X.
X, okay? What's our other ratio gonna be? Cody?
BQ
BQ over,
and TS.
well, remember, if you're gonna go in that order for that one, let's go in the same order for the VQ,
ST.
T. It's the same side, I get that, but let's name them in the same order, okay? VQ is 6 centimeters long and ST is 3.6, okay. So we're ready to set up our proportion now, using those two ratios. 10 over X equals 6 over 3.6. And yes, I want you doing it this way first. I want you to set up your ratios first. What are the possible ratios that you could use? Then pick the two, in this case we only had two, and set up a proportion with them, and then use your proportion solving skills to solve for X. This is a no calculator one. Works out pretty nice. What's X equal?
6
6 what?
Centimeters.
Centimeters, yeah, 6 centimeters. We get the missing side length is 6 centimeters. Okay, everybody get that?
Yep.
Okay, look at our next one. It says triangle ACD is similar to triangle ABE. These are easier to do if you actually redraw it when one of the figures is on top of the other. So let's take our triangle ACD that they say, so ACD. So A is up here, C is here, D is here. Let's rename the side lengths. Okay, so how long is side AD? 12. Because it's 8 centimeters from A to E, and from E to D it's another 4, so altogether we have a 12 centimeter side length. And then side DC is X centimeters. And do we know what side AC is? No, okay. Now let's draw our other triangle ABE. So A, the B is here, and the E is over here. What do we know about triangle ABE? Side AE, do we know it?
No. Or yes.
How long is it?
8.
It's 8 centimeters. Do we know how long EB is? How long is it? 5 centimeters. Do we know how long AB is? No. So, well, that's okay. We got enough here to help us get two ratios set up, right? Okay, so we could do, and because we have it drawn really nicely like this here, where they're like in the same position exactly, should be really easy to do. Side AD corresponds with which side? AE. And in the name, does it work out? Let's go back up to the names and see if it works out. Does AD correspond with AE?
Yes.
Yeah. Okay, so AD we know is 12, and AE we know is 8. DC, coming from the same triangle, we had AD upstairs in that one, so we got to use the same. DC over EB, those should be corresponding. Bottom of each triangle, let's see if it works in the name. DC corresponds with EB.
Yes.
Works out in the name too. So DC is X, EB is 5. We have our ratios to set up in a proportion. Okay, go ahead and finish solving that one. How long is side DC? I actually get, and I should put what I got in the first place. The way I did it without a calculator, I got this.
What's another name for 7 and 4/8?
7.5.
7.5. What's another name for 7 and 4/8?
7.5.
Okay, 7 1/2. And what is the label on these?
Centimeters.
Centimeters. So whichever one or the other of these, I would probably go with that one because I just happen to like fractions better than I do decimals.
Okay, think you got this? The most important part is what in this. How are you gonna get the right answers? How are you gonna set yourself up for success? Where's it all gotta start?
Our notes.
No, where's it all gotta start in here when you're doing these? You can't set up good ratios. Are you gonna be able to set up a good proportion?
No.
No, you have to set up good ratios first to help you be successful in putting a ratio equal to a ratio, making a proportion. Because you guys got that solving proportions down. You guys mastered that last lesson. Yes, Cody?
That's something that sort of goes with math that I sort of learned in